Hello, my name is Mark, and this is part 9 of Power Supply Current Saver Proof It's Feasible. Now, last part, I had two of these ceiling fan capacitors connected in series, and I was trying to connect. I had two of these little bulbs connected in, I thought they were in parallel, but they were in series, and the current bypassed the capacitors altogether. So I hope you read the description in the last part 8. I talked about that. So now what I've done here is I've wired these two capacitors in parallel. And then I connect the light bulb, the red light bulb here, in series with the two capacitors. And I've got it hooked up here for the voltmeter. When I turn it on, what happens is it generates about 35 volts instead of 30 volts that's coming out of the two parallel branches, because I have 15 volts coming out of this 10-to-1 step-down transformer that has about 125 volts feeding into it. So it puts out 15 volts. It'll make 30. And I'm getting about 35 volts altogether. So 5 volts is dropping over this little light bulb. Not quite, but close to it. And there's about 30 volts dropping over the capacitors. So I think what's going on is because the capacitors are like little batteries, they're charging and discharging. Somehow they're generating a little bit more voltage, maybe current too. Now, in my next experiment, I'll add another one of these in parallel, and I have a fourth one, and I'll see how close I can get to 12 volts, which is what this little bulb is designed for. Now, the problem, you won't get that exact, and you have to calculate parallel capacitances to get the right value, but they probably won't make the right values. So the solution is to use a variable capacitor that can tolerate 240 volts when I do my experiments, raising the voltage to 240 volts. So we're really glad it's working now though. And I can use this when I make a good video of it later. So I'll turn it on now, and we'll take voltage and current measurements. Plug it into the wall. There's the little light on. You can barely see it because it's only at 5 volts. Turn on the voltmeter. There it is. It's reading about 4.9. It's up to 4.94 volts. It's just close to 5. Yep, 4.95 it went up to. So now all I have to do is take this guy out of here and touch him over here. If I can get him in there somewhere. And it reads just over 30 volts. Well, yeah, it fluctuates between 29 something and 30 volts. So where's that extra almost 5 volts come from? I don't think I can measure 30 volts on here. So now we'll test the current. I'm going to take that out of there. better pull these out of here. They'll get on my way. This wire should work. Oh, 0.15, 0.16. That's less than it was before. It was generating 0.23 before in the last part. 8, I think it was. Oh, it goes down a bit too. So, I hope that's correct. Just try it on this black wire here. It's 0.9. This was 0.1. Okay, hopefully it's less down here coming out of the wall. I can't remember from the last test. Oh, look at that, 0.45. So that's 50% right there. Oh, a little less than 50%. It was 0.06. Well, it goes down to 0.4, so say what's it say here? 0.0. I need some more light here. 0.045. 0.04, 0.05. What was it here? 0.11. Yeah, so that'll be 50% or a little over. So that's really good. 50% was what I expected. So actually the last part saved more electricity wired up, but had the problem of having two devices hooked up to it at the same time. They would have to be the same device, same make and model and settings on them, which would be a little inconvenient. Okay, so I guess that's all I need to say about that until the next video. Thank you for watching. Goodbye.